All right, before we do the next example, let's go back to some algebra review so we can see how we would solve these algebraic expressions or equations before we apply it to our trig equations. So if you look at these three algebra equations, you might notice that they have a couple things in common. Each one of these equations has a term that involves or includes an x squared. They also have a term with an x in it. So they all have an x squared and an x. These are all quadratic equations, okay? One thing that tells me is that each one of these equations should have two solutions, okay? Now, anytime I'm dealing with a quadratic equation, an x squared, something with an x squared and something with an x, what I always do first is move everything to the same side of the equal to sign. So you can see in the first equation that the x is kind of over to the right side. We want to move that positive x over to the left side. I'm going to do that by subtracting x to both sides. When I subtract x to both sides and put it in standard form, that leaves me with an equation that says 3x squared minus x equals 0 now, right? And so now I can try to solve this equation by factoring. You might notice that I have two terms in this equation, and each of those terms at least has an x in them. So we should be able to GCF out an x, factor out an x, and leave our leftovers. If I were to factor out an x, that would leave me with a 3x minus 1. You can always double check by kind of redistributing that. You should end up getting back to where you started, right? So I'm going to factor out an x, leaving me with a 3x minus 1. Now, this says that x times 3x minus 1 should equal 0. I have two factors, two things being multiplied, where the answer is 0. If that's the case, if I have two things being multiplied and the answer is 0, either the first term, x has to equal 0, or the second term, 3x minus 1 has to equal 0. What that allows me to do is set up two small equations and solve to find both of my solutions. I end up getting x equals 0, that would be a solution that satisfies this equation, or x equals 1/3, that would be a solution that also satisfies this original equation. Okay? What's important on this one, I want you to notice that we didn't divide by x. We factored out an x because that's an important piece of our equation that actually gives us a solution. If we tried to divide out an x, then that x kind of goes away, disappears, and then I'm missing a solution that I should have, okay? I want you to keep that in mind when we go to do our trig equations, that you shouldn't ever be dividing anything away. You should be factoring it out, okay? All right, look at the middle equation. My middle equation also includes an x squared and an x. It also includes a third term, so we have a trinomial here. What we can do to solve this is try to make this kind of look like a FOIL problem, right? We want to find the factors, the two things that multiply, to give us our original equation that equals 0. And so what we want to do is we want to break this up into little factors so that if we were to redistribute or FOIL it out, I end up getting an x squared minus 5x minus 6. Okay, so I can break the x squared down into x and x. We now need to figure out what numbers multiply to give me a -6, that when I add together, they give me a -5. It has to be in that order. It has to multiply to the last term, the -6, and add to give me the middle term, the -5. So you might have to go through some factors and see which ones work, making sure the signs work for all of it. You should end up getting a -6 and a +1, right? If you were to FOIL this out, x times x is x squared, x times 1 is 1x, -6 times x is -6, and if you were to combine those like terms, you get that -5x in the middle. And then your last term would be the -6 times the 1, which is our -6, okay? Now that we have the equation factored, again, we have two things being multiplied where my answer is 0. As long as I have it completely factored, and my equation is set equal to 0, I can use that 0 product property to say, well, either the first one has to equal 0 or the second one has to equal 0. So if x minus 6 equals 0, I can add 6 to both sides and I can say that x has to equal 6. I can set the x plus 1 equal to 0, solve, and get x equals -1. So again, I have two solutions. Remember, I knew that from the beginning because of my highest degree. I have x equals 6 that would work, and I have x equals -1 that would work. Okay, again, factoring, like reverse FOILing, right? Basic factoring. All right, the last one is also a trinomial. It has 3 terms with an x squared and an x, and that last term without a variable. The difference on this one is it looks like we have a leading coefficient other than 1. So we have a 3x squared this time. And there is no common factor, GCF, that we can factor out. Now, there are a bunch of different ways that we can factor this type of problem. There is a C method, split the middle term. Some instructors use a method called bottoms up. Whatever method you've learned and you like, just make sure that you show your work so I can see where you're going. But we need to factor this in order to solve. Okay, so one of the ways is we can imagine taking this 3, multiplying it by the -20, and that answer is going to give us a -60. Okay, what we can do then is figure out what numbers multiply to give me -60, that when I add them together, I get 7. Again, what numbers multiply to give me that last term, with the first term and the last term multiplied, -60, that are going to add to give me +7. You might have to try a few, but I found that +12 and -5. They multiply to give me that -60, but if I add them together, I get the +7 that I need for my middle term, right? Okay, so what this allows me to do is it allows me to rewrite my original equation, and instead of using a 7x, I can use the 12 and the -5 instead. So my first term is still going to be my 3x squared. My two middle terms now, instead of calling it a 7x, I'm going to call it a 12x minus 5x, because isn't really that the same thing as 7? Just split up into two different numbers that equal a 7x, and then I have my -20. Okay, this is called split the middle term. Once I have done this, I can factor by what we call grouping. I can group these first two terms, and I can group these second two terms. In the first group, we're then going to look for a GCF, a greatest common factor. It looks like in this group, I can factor out a 3 and an x. If I factor out a 3 and an x, that would leave me with an x plus 4. I'm going to do the same thing in that second group. I'm going to look to see what GCF I can take out of -5x minus 20. It looks like I can take out a -5. When I take out a -5, I should be left then with, again, an x plus 4, which is perfect. That's what's supposed to happen. These, what I call leftovers, are supposed to match. Because they match, they are a greatest common factor again, right? Both of my terms now, both this piece and this piece have a common factor. They have an x plus 4 in common. So I can actually factor out that x plus 4 as a common factor. That would leave me here with a 3x and here a -5. Again, I factored out the greatest common factor of the x plus 4. They both had that in common. And then I was left with a 3x minus 5. This is the factored version of my original question. If you FOILed that out, you end up getting the 3x squared plus 7x minus 20. We've just factored it. It's set equal to 0, so now we can also solve it. Again, since I have two factors, two things being multiplied that equal 0, I can set each piece equal to 0 and get my two solutions. I can say that x has to equal -4, or x could equal +5/3 by solving each of those factors. All right, so hopefully that was a quick algebra review. I want you to keep those in mind as we do our trig equations, because we're going to do them in a similar fashion.